Okay, welcome back. This is the second part of the 3.5 notes, and I just want to go over some examples on calculating the derivatives using a lot of the rules that we already have. And so what I want to do here, this first problem is going to require quite a bit in order to find the derivative. So let me just use the notation. If I take d dx of y, then I'm going to do d dx of x squared times cotangent of x. And then I'm going to do this. I'm going to do minus d dx. And instead of writing 1 over x squared, I could use the quotient rule here. I'm just going to change this to x to the negative 2 power. Okay? And so what I'm going to get here, so I'm going to get dy dx. And I'm going to move this down because I got to do a few things. Okay, before I do anything, I notice that I have the product of two functions here. So I'm going to have to use the product rule. So I'm going to call this u, call this v. So u is equal to x squared, v is equal to cotangent of x. U prime, if I take that derivative, I get 2x. And then the derivative of cotangent x is negative cosecant squared of x. Okay? And I'm going to cross multiply and add these together. So my derivative, dy dx, is going to be equal to 2x times cotangent of x, and then minus, even though it's plus, I'm multiplying by negative, I have negative cosecant squared x. So cosecant, no, let's not skip any steps. Let's do plus x squared times negative cosecant squared of x. And then the derivative over here, I have minus, and then I'm going to do the power rule. So I'm going to do negative 2, squared x, minus, I've got negative 2 times x to the negative 3 power. All right, so let's simplify this a little bit. Let's get dy dx over here. So we've got, let me do 2x cotangent of x minus x squared cosecant squared of x, and then plus, and I'm going to do 2 over x cubed. Okay, so we could probably simplify this more. I just want to go through the steps on how to break down these problems where I see that I have, the product rule or the quotient rule, where I can use the power rule, how to rewrite things, and all that. So let's go ahead and move on to the next problem. Okay, this one's a little bit interesting. I could do the product rule here and call this part u and call this part v. That's one way of doing it. But what I see here, and this may not be as apparent to you, but I'm gonna multiply and distribute my secant of x in here and see what I get. This might make it a little bit simpler. So if I have y equals, let me do this. Let me do secant of x times sine of x, and then plus cosine of x times secant of x. Okay? And I'm going to rewrite secant as 1 over cosine. So I'm going to write this as y equals 1 over cosine of x, and then times sine of x over 1. And then plus cosine of x over 1 times 1 over cosine of x, okay? So what I end up getting here, it's kind of interesting, but I end up getting sine of x over cosine of x. This gives me tangent of x. And then I get cosine of x over cosine of x. I just get 1 here. So what I've done is I've taken this expression. We could have done the product rule, but I went ahead and tried to simplify it first, and I ended up getting this function that's much easier. So now if I wanted to find dy dx, which is the same thing as y prime, then I'm going to end up getting secant squared of x plus 0. So y prime, I just get secant squared x. Okay? We would have gotten that same answer by doing the product rule, but that probably would have required quite a bit more work and a lot more simplification on the end. So let's go ahead and take a look at the next one. Okay, now this one, this is going to require the quotient rule. Okay, I can't simplify anything from my numerator to my denominator, So let's go ahead and use the quotient rule. I'm going to identify my high function, which is cosine of x. I'm going to identify my low function, which is 1 plus sine of x. And so if I take the derivative of my high function, that's going to give me, the derivative of cosine is negative sine of x. Okay, the derivative of my low function is going to give me the derivative of 1 is 0. The derivative of sine is just cosine of x. Okay, so let's go ahead and apply our quotient rule and find dy dx. So I've got my low function, so low d high minus high d low over low low is going to give me 1 plus sine of x, and that's a quantity, okay, times the derivative of my high, so that's negative sine of x, minus the high function, which is cosine of x, times the derivative of the low, which is cosine of x. All right, and then this is all over the quantity 1 plus sine of x, that quantity squared. Okay, so this is unsimplified. As long as you guys are getting to this point, I'm happy. Let's go ahead and try and simplify this. So dy dx is going to give me, I'm going to distribute my negative sign here. So I get negative sine of x minus sine squared of x minus cosine squared of x. Okay, all over 1 plus sine of x quantity squared. Okay, now I can simplify this a little bit. I'm going to end up getting this. I'm going to end up, here's what I can do here. It's kind of hard to see. I'm going to factor out a negative out of here. I'm going to do this as negative sine of x. And then I'm going to do this. I'm going to do plus, factor out a negative 1 out of sine squared x and cosine squared x. So if I factor that out, I get sine squared of x plus cosine squared of x. And then this is all over the quantity 1 plus sine of x squared. Okay, so then what I can do, I know that this part goes to 1. So then dy dx is equal to negative sine of x minus 1, all divided by 1 plus sine of x quantity squared. Okay, now I'm going to factor out a negative 1 here because I see something unique. If I factor out a negative, then I'm left with sine of x plus 1, and then this is all over the quantity 1 plus sine of x quantity squared. Now, I have 2 of these down here, so let me rewrite it so you guys can see it. So negative 1, and I'm going to reorder my numerator here real quick. I'm going to do 1 plus sine of x, and then this is all over 1 plus sine of x times 1 plus sine of x, and these end up dividing out. So this does simplify down to something pretty useful. So then dy dx is going to be equal to negative 1 over 1 plus sine of x. Okay. And that one doesn't really have, some of these will simplify down, guys, but there is no like significant pattern with these. Okay. Let's go ahead and take a look at the next one, see what we get here. Okay, this one isn't too terrible, but this says find ds dt. So look, my independent variable is t, and my dependent variable is s. So what I'm going to do is I'm going to take ddt of everything, so take that of s, and then take ddt of t squared minus secant of t plus 5e to the t. And so, guys, I'm doing the same thing. It's just I got to realize that t is kind of like my x, and s is like my y. So I'm going to get ds dt, the derivative of x with respect to t, is equal to, let me do the power rule here on t squared, so I get 2t, and then I get minus, the derivative of secant t is secant t times tangent t, so minus secant of t times tangent of t, and then the derivative of 5 times e to the t is just plus 5e to the t, okay? So some of these, if you know your rules, will be pretty easy for you, okay? And let's take a look at this last one. Again, I've got one function, 1 plus secant of theta, times sine of theta. I could do the product rule here and call this u and call this v, but I'm going to try and see what happens if I multiply this through and try and simplify it before I take the derivative. Okay, so I'm going to multiply this out. And so I get r is equal to sine of theta plus secant of theta times sine of theta. All right, and so I get r is equal to sine of theta. Let me rewrite secant of theta. I shouldn't have a plus there. Let me rewrite secant of theta as 1 over cosine of theta. So plus 1 over cosine of theta, and then times sine of theta. So what happens here is I get sine of theta. Sine over cosine gives me tangent of theta. So if I don't have to do the product rule, folks, I don't want to, okay? Sometimes it's easier just to go through this and simplify it before you take the derivative. So now I'm going to take the derivative with respect to theta here. So dd theta, all right? And so as a result, I'm going to get dr d theta, the rate at which, or the derivative of r with respect to theta. And the derivative of sine is going to give me cosine theta. The derivative of tangent gives me plus secant squared of theta. And that's it. Okay. So if you know your rules, this is easy. We got to combine rules. We got to combine the quotient rule, the product rule, power rule, all those rules we've already learned, guys. We've got to all use them. Okay. So I hope that this is okay for you. Get started on your homework, and please come in if you have any other questions. Thanks.